All right, hello. This is a Calculus 2 final exam review. So, in addition to the methods I said you should study on a class email, here's another one I forgot to say. Also, try some of the odd-numbered book problems in the appropriate sections. Just study the sections that will be on the final. And then you can check your answers in the back of the book or ebook. That's another way to study for the final. Okay, so here's question 1. We're going to go over chapter 12 today, more chapter 12. And by the way, as you can see there, there's going to be no chapter 9 or 10 on the final. So do not study chapter 9 or chapter 10. They will not be on the final exam. But the other chapters will, 6, 7, 8, and 12. I believe we skipped chapter 11. Anyway, you can get the exact sections from a prior email. Okay, so here's the first question. Find all values of theta that satisfy the equation sine theta equals 1/2 over the interval 0 to 2 pi. So the first thing to notice is we're looking at the sine of an angle that's positive. Where is sine positive? If you remember that little chart, all students take calculus, right here. All students take calculus. Everything is positive in quadrant 1, and then in quadrant 2, sine is also positive. So sine is positive in quadrant 1s and 2. So theta is going to be in quadrant 1 and quadrant 2. And the easiest way to do that is to look at your trig sheet, which I'm going to show you in a second. But here's the answers. In quadrant 1, we're going to see theta is equal to pi over 6. In quadrant 2, theta is going to be 5 pi over 6. So those would be the answers to this equation. When theta is that quadrant 1 angle and that quadrant 2 angle, you'll get 1/2. And again, the quadrant 1 angle is pi over 6 and 5 pi over 6. Let's show that's really true. So here's my quadrant 1. Notice the sine of pi over 6, which is the same thing as 30 degrees. To find the sine of an angle on a unit circle, you look at the y coordinate. The sine of theta equals y. There's the 1/2, which is positive. Notice in quadrant 4, it's negative. So you don't want 11 pi over 6 because the sine of that angle is a negative 1/2. So sine is positive in quadrants 1 and 2. And the sine of pi over 6 is what we want to get the 1/2. And then in quadrant 2, notice when the angle is 5 pi over 6, which is quadrant 2, y is equal to 1/2. There you go. Let's go to the next question now. Next question is verifying a trig identity. Secant theta minus sine tan is equal to cosine. So how are we going to verify this identity? Well, we're going to start with the more complicated side, the left-hand side, and then we're going to change everything to sines and cosines where we can. So in particular, secant is the reciprocal of cosine. Tangent is that sine over cosine. So have those identities handy. That will help us verify these trig identities. So that's what we did here. So solution, put the left-hand side in terms of sine and cosine. So instead of writing secant theta, we're going to write 1 over cosine theta by the reciprocal identity. Minus, instead of sine times tangent, we're going to write sine times sine over cosine is another name for a tangent. And then let's simplify this. So this is going to be 1 over cosine again, minus sine times sine is sine squared over the cosine theta. This is like over 1. So when I multiply the denominators, I just get cosine theta. So at this point, I have a common denominator. We can write it as a single fraction, 1 minus sine squared. Let me write that down because I skipped that step. So you could write 1 minus sine squared theta over cosine theta. So it doesn't hurt to show that step. So from here, because we have a common denominator, write it as a single fraction with that common denominator where we're going to subtract the numerators. And then do you recognize this as a Pythagorean identity? Because isn't sine squared plus cosine squared equal to 1? So if we subtract sine squared to each side, you're going to get cosine squared theta. So 1 minus sine squared theta is cosine squared theta by that trig identity. Let me write down that trig identity. Sine squared theta plus cosine squared theta equals 1. That's a Pythagorean identity. And what's another name for 1 minus sine squared? Well, if I subtract sine squared to each side, I'm going to have cosine squared theta equals 1 minus sine squared theta. So 1 minus sine squared theta is cosine squared theta. And then what's cosine squared theta over cosine theta? It's just cosine theta. And that's exactly what we wanted. We wanted cosine theta because that is the right-hand side. So we've shown the left-hand side is equal to the right-hand side. And we're done with that problem. Okay, let's see what the next problem looks like. Number 3, converting degrees to radian measure. So this is where you want to use the unit multiplier, either pi over 180 degrees or 180 degrees over pi, depending on the situation. So since I want to go from degrees to radians, I want to go pi over 180 degrees, so the degrees will cancel, because that's another name for 1. So that's what I did here. I wrote negative 240 degrees times that another name for 1 is pi radians over 180 degrees, because pi radians is 180 degrees. And now the degrees cancel, which is what we want, because we ultimately want radian measure, no degrees. So, and then I canceled the zeros in division, so I've got negative 24 pi over 18, and then 6 goes into 24 and 18, so when you divide them each by 6, you get negative 4 pi over 3 radians. Done. That's the same angle as the minus 240 degrees. Don't forget to write that minus sign. If your degree angle is negative, then the radian measure will be negative. Okay, let's do the flip-flop. Convert radians, 7 pi over 2 radians, to degree measure. So here again, I'm going to use that unit multiplier. But now, since I want degree measure, you want degrees on top. So write 7 pi over 2 times, another name for 1 is 180 degrees over pi. The pi's cancel out, and I'm left with just degrees. So 7 times 180 degrees over 2 is what that simplifies to. 180 divided by the 2 is 90. 7 times 90 is 630. So there it is, 630 degrees. Done. Done with that problem. Number 5. In which quadrant is negative 11/4 pi radians? So these are all good questions that you're going to see these on the final exam. So how would you do this problem? So notice that it's a negative angle there. Okay, so what I did was I got a positive coterminal angle. Remember, coterminal angles have the same terminal side, so they're going to be in the same quadrant. So I like to get it, in the interval from 0 to 2 pi. That makes it easier. If I just add 2 pi, which is a complete revolution, to this angle of negative 11/4 pi, my angle's still going to be negative because 11 divided by 4 is more than 2. So instead of adding 2 pi, I'm going to add 4 pi because any multiple of 2 pi is a full revolution, which means you'll have a coterminal angle. So let's see what I wrote here. Let's get a positive coterminal angle by adding a multiple of 2 pi. And again, I did 4 pi. 2 pi plus 2 pi is 4 pi. And when you get a common denominator of 4, and when you add those fractions, you're going to get 5 pi over 4. So notice that is a positive angle, so it's easier to deal with, and it's in the interval 0 to 2 pi. So think of 5 pi over 4 as pi plus pi over 4. Because 5/4 is a little bit more than 1. It's going to be in quadrant 3. 5/4, the number in front of pi is 5/4. 4/4 is just 1, so that's pi, plus another pi over 4 would give you the 5 pi over 4. So we're going to be obviously in quadrant 3. Pi over 4 is like 45 degrees. So there is my little picture. When I go from the positive x-axis to the negative x-axis, that's a half of a revolution. That's pi. And then we got to go a little bit more, pi over 4. So the terminal side's in quadrant 3. Quadrant 3. So that's our answer. Okay, let's try another one like that. Number 6. In which quadrant is 400 degrees? Well, here again, it's nice to get your interval in 0 to 360, a full revolution. So to make this angle smaller, I'm going to subtract a full revolution of 360 degrees. Remember, 360 degrees is the same thing as 2 pi radians. So if you're given degrees and you want to make the angle smaller, subtract off some multiple of 360. Here, just 360 is good enough. So let's find a coterminal angle by subtracting 360 degrees. So what's 400 minus 360? 40 degrees. And 40 degrees is clearly in quadrant 1. And there's the picture. So quadrant 1. Okay, so that takes care of those problems. Let's continue with one more problem I want to do. And that comes from chapter 8, I believe this is. I want to find the average value. Find the average value for this function. So find the average value for f of x comma y equals 6x squared y cubed on region R, where region R is defined to be all x from 0 to 2, all y from 0 to 3. So again, you're allowed to use your notes. There's going to be a problem like this. We said that already because I think, I don't know if my memory serves correctly, something like 8.8. They cover average value, and that's the only thing you have to know in that section is average value, wherever that section happens to be. Okay, so know the formula. To find the average value, remember we said it was the double integral, which is the volume, divided by the area of the region. Divided by the area is the same thing as writing just 1 over the area in front. It doesn't really matter. So it's the double integral divided by the area. Another way of saying divided by the area is saying multiplying by 1 over the area. Okay, so let's take a look at this last problem. And I'll do more videos, so keep on looking for videos and keep on looking for learn announcements and class emails. Remember, the final exam is not going to be on Monday. You have to check what I wrote for your sections. Yeah. Okay, so let's draw a sketch of what's going on here. When x is varying from 0 to 2 and y is varying from 0 to 3, x goes from 0 to 2, y goes 0 to 3, you get this rectangle, a 2 by 3 rectangle. And what's the area of a rectangle? Length times width. So the area is going to be 2 times 3, which is 6. So let's rewrite f average as 1 over 6 because the area of R is 6. So it's 1 over 6. And then, because this is a rectangular region, the order of the integration does not matter. So I just went from x equals 0 to x equals 2, y equals 0 to y equals 3. See, y goes from 0 to 3. And since my y is on the inside integral, that's why I got dy first, and then the dx on the outside. And then here's our function, f of x comma y, that was given, 6x squared y cubed. So this is the way we're going to set it up for the f average, the average value. And notice the 6 cancels with the 1/6. These just cancel. So now I just rewrote it like this. We don't need those numbers anymore. They cancel out. So it's just going to be the integral from 0 to 2. Let me just get this. Sorry for the quick little delay there. Okay. Oh yeah. So we just got this double integral. So make sure you feel comfortable evaluating double integrals. That will be on our final exam. Okay. And remember, you do get 2 attempts for each question. But after your first attempt, it will not tell you if you got it right or wrong. But if you feel like you got it wrong, you can try it again. But try to be aware of the time and have everything organized as I said before. Okay, so to do this double integral, we're going to do the inner integral first. So from 0 to 3 of x squared y cubed dy. Remember, these are y's. So I'm doing the inner integral first. And because I'm integrating with respect to y, you treat x squared as a constant. So this answer is going to be x squared times y to the 4th over 4. X squared times y to the 4th over 4. And then we're evaluating from y equals 0 to y equals 3. And you always input the 3 first, the upper one. So wherever you see y's, you're going to write 3. So it's going to be x squared times 3 to the 4th over 4 minus, and then when y is 0, this whole thing disappears. So here we go. So my final answer for the inner integral is just 81/4 x squared, because 3 to the 4th is 81. Subtracting 0 doesn't change anything. Okay, so now we plug that into the outer integral. So here's the outer integral. We're going to go from 0 to 2, x equals 0 to x equals 2 of 81/4 x squared. I pulled out the 81/4, And then the integral of x squared, whenever you're doing a definite integral, first do the indefinite integral. So what's the indefinite integral of x squared? It's x cubed over 3. And then you do the evaluation from x equals 0 to x equals 2. I pulled out 81/12 because isn't 81/4 times 1/3? That's going to be 81/12. And then we're going to input the 2 first. So 2 into x cubed is just 8 minus 0. And then 81/12 times 8 minus 0, after all the simplifying, you get 54. And we are done with that. Done with that. Okay, so that's it for today. And I'll talk to you later. Have a good one.